In this video, I'm going to explain the equipment and function of each of the pieces of equipment in a commercial boiler room. First is the water softener skid, which is here on the left of the screen. The next is the surge tank. Next is the deaerator tank. Two boilers, a chemical treatment skid, flash tank, and a condensate receiver tank. I'll do a brief summary of what the boiler does, and then we'll go into the function of each equipment piece within the room. The boiler is the heart of the steam plant. It transfers heat from burning fuel into water, producing steam that is distributed throughout the building. Natural gas is burned inside the combustion chamber. Heat passes through tubes surrounded by water, causing the water to boil and produce steam. The steam is used for building heat, domestic hot water generation, humidification, sterilization, and equipment processes. The fuel source is highlighted in yellow, which is natural gas. The first piece of equipment is the water softener skid. The water softener skid removes hardness minerals, primarily calcium and magnesium, from the incoming domestic water before it enters the boiler system. Hard water creates scale inside boiler tubes, heat exchangers, and piping. Even a thin layer of scale acts as insulation, reducing heat transfer, increasing fuel consumption, and shortening equipment life. Commercial boiler plants use ion exchange resin to replace hardness minerals with sodium ions. The softener periodically regenerates using a brine solution to restore its capacity. Its purpose is to prevent scale buildup, improve boiler efficiency, reduce maintenance costs, and extend equipment life. The next piece of equipment is a condensate surge tank. The condensate surge tank collects hot condensate returning from the steam system before it is pumped back to the deaerator. As steam gives up its heat throughout the building, it condenses back into water. Rather than wasting this hot water, it is recovered and reused. The surge tank provides storage volume that accommodates fluctuations in condensate return and allows duplex condensate pumps to deliver a steady flow to the deaerator. The purpose of it is to collect returning condensate, recover heat in treated water, prevent pump short cycling, and maintain a consistent water supply to the deaerator. The next piece is the deaerator tank. The deaerator removes dissolved oxygen and carbon dioxide from boiler feed water before it enters the boilers. Oxygen is one of the leading causes of internal boiler corrosion. The deaerator helps heats the feed water to near saturation temperature, allowing dissolved gases to escape through a vent. It also serves as a storage tank for boiler makeup water and provides positive suction pressure to the boiler feed pumps. The purpose of it is to remove oxygen and carbon dioxide, prevent corrosion, store boiler feed water, improve boiler efficiency, and increase boiler life expectancy. Next is the chemical treatment controller. The chemical treatment system continuously monitors boiler water quality and automatically injects treatment chemicals into the boiler system. Proper water chemistry prevents corrosion, scaling, and sludge buildup inside boilers and piping. The typical chemicals that it controls are pH, oxygen scavenging, scale inhibitors, corrosion inhibitors, and conductivity. Many modern systems automatically feed chemicals based on conductivity or other water quality measurements. The purpose of it is to protect the boiler, maintain proper water chemistry, reduce maintenance, improve operating efficiency, and extend equipment life. Next is the boiler. The boiler is the heart of the steam plant. It transfers heat from burning fuel into water, producing steam that is distributed throughout the building. Natural gas is burned inside the combustion chamber. Heat passes through tubes surrounded by water, causing the water to boil and produce steam. The steam is used for building heating, domestic hot water generation, humidification, sterilization, and process loads. After giving up its heat, the steam condenses back into water and returns to begin the cycle again. The purpose of it is to generate steam, supply thermal energy to the building, operate efficiently under varying load conditions. Next is the surface blowdown controller and solenoid valve. The surface blowdown controller automatically removes water from the surface of the boiler to maintain proper water quality. As steam leaves the boiler, dissolved solids remain behind. Over time, these dissolved solids become concentrated and cause foaming, carryover, scaling, and poor steam quality. The connectivity controller continuously measures the concentration of dissolved solids inside the boiler. When the connectivity exceeds the programmed set point, the controller energizes the blowdown solenoid valve, allowing a controlled amount of water to discharge from the boiler. Fresh, treated makeup water then replaces the discharged water, restoring proper water chemistry. The purpose of it is to maintain proper connectivity, remove dissolved solids, improve steam quality, prevent scale formation, and protect boiler efficiency. Next is the flash tank. A flash tank, also called a flash vessel or blowdown flash tank, separates flash steam from high temperature condensate or boiler blowdown by reducing the pressure inside the vessel. When high pressure hot water or condensate enters the flash tank, the sudden pressure drop causes a portion of the water to instantly vaporize into low pressure steam. The flash steam rises to the top of the vessel and can be recovered for low pressure heating applications, routed to a deaerator, vented depending on the system design. The remaining hot condensate collects in the bottom of the tank and flows to the condensate receiver or drain. Recovering flash steam allows the facility to capture energy that would otherwise be wasted, improving the efficiency of the boiler plant. The purpose is to recover usable energy from high-pressure condensate or boiler blowdown, separate steam from condensate, reduce pressure safely, improve overall boiler plant efficiency, protect downstream piping and equipment from high-pressure discharge. Lastly is the condensate receiver tank. The condensate receiver tank collects condensate returning from the steam system and serves as a storage reservoir before the water is pumped back into the boiler feed water system. After steam transfers its heat throughout the building, it condenses back into hot water. That condensate flows through the return piping into the receiver tank. Because condensate returns are rarely constant, the receiver acts as a buffer, storing water until the condensate pumps are activated. Duplex or triplex condensate pumps automatically cycle based on the water level in the tank, delivering condensate to the deaerator or surge tank directly to the boiler feed system depending on the plant design. Since condensate has already been heated and chemically treated, recovering it significantly reduces fuel, water, and chemical consumption. The purpose is to collect returning condensate, store condensate until pumping is required, supply water to the deaerator or surge tank or boiler feed system, recover heat and treatment chemicals, and reduce makeup water requirements. In summary, think of the boiler room as one complete cycle. Fresh water enters through the water softener, condensate returns from the building into the surge tank, the deaerator removes oxygen, chemicals protect the system, the boiler produces steam, and the blowdown controller continuously maintains water quality. Every component plays a role in keeping the plant efficient, reliable, and protected from premature failure. If you like this video, please hit subscribe to this channel. Thank you.